number problems. Our question here says, for each of the following comparison sentences, write let statements for each unknown. And then our first sentence says, the number of cats is 5 less than the number of dogs. So a comparison sentence is a sentence that compares two things. It tells you a little bit of information. So here in this sentence, it is comparing the number of cats and the number of dogs. A let statement is how you start a word problem by introducing a variable and then telling me what we're going to use for the number of cats and what we're going to use for the number of dogs. And then each unknown, as we already said, would be we don't know what the number of cats is, we don't know what the number of dogs is. So when I'm facing a word problem, I'm going to read it. So it says the number of cats is 5 less than the number of dogs. This is not a complete word problem. It is just one sentence out of a word problem. First thing I want to do, identify my unknowns, right? So we are missing the number of cats and the number of dogs. So I'm going to start by letting, so I'm going to say let something, and I'm not sure yet, so I'm just going to leave some space and we'll come back to that. I'm going to let something be the number. And I'm a little lazy and I don't usually write out the full word number. I usually just write the number sign of cats. I'm going to let something else, still going to wait and think about that, be the number of dogs. Now in my sentence, it said the number of cats is 5 less than the number of dogs. So I'm comparing the number of cats to the number of dogs. So my basic rule that I follow is the thing that was mentioned last in the comparison sentence, which in this case is the number of dogs, is the one that I'm going to let be X. You could choose N or D or something else, but I'm just going to pick X. So I let X be the number of dogs because the number of cats is being compared to the number of dogs and because the number of dogs is the last thing mentioned in the question. So then all you really need to do for the number of cats is translate. So the number of cats is 5, that's a number, less. Less means we are going to subtract, but it is less than. Anytime I have the word than or from, that tells me that it's actually backwards. So it's not 5 minus something, it's going to be something minus 5. So it's 5 less than the number of dogs. Well, the number of dogs is X. So it's going to be X, the number of dogs, minus 5. So I'm going to let X minus 5 be the number of cats and let X be the number of dogs. And then from here, there would normally be more to the word problem and then we could solve it, but this is just one single comparison sentence. Our second comparison sentence says the length of a rectangle is 4 more than 3 times the width. So the first thing I want to do is identify my unknowns. I notice we don't know what the length is, we don't know what the width is. So I'm going to let something, I'm going to think about it, be the length. And I'm going to let something be the width. Okay, so if I look at it again, the length of a rectangle is 4 more. More means plus. More than, that word than means it's actually something plus 4. 3 times the width. The last thing mentioned is the width. The length is being compared to the width. So I'm going to let the width be X. And then the length is 4 more than, so it's something plus 4. 3 times the width. Well, 3 times the width would be 3 times the width, which we said was X, so 3X. So this is 4 more than 3 times the width, because we said X was going to be the width. So we have let 3X plus 4 be the length, let X be the width. So we're going to try out a full problem. It says the number of phones that Sarah has is 5 less than double the number of TVs. She has a total of 10 TVs and phones. How many of each does she have? So this is a full word problem. It has more than just the one comparison sentence. So when I read through my problem, I do try to find that comparison sentence. So usually in a question, you're going to have something that is a comparison and something that is what we're going to build our equation out of. Often that's going to be a total of some sort. So the first sentence says, the number of phones that Sarah has is 5 less than double the number of TVs. That is my comparison sentence. We are comparing the number of phones and the number of TVs. And then it says, she has a total of 10 TVs and phones. This is telling me what those are going to add up to, which is something I can build an equation around. So the first one is just a sentence comparing phones and TVs, and then our second one here tells me an actual total. So when I go to tackle this question, I try to do it in little baby steps. The first thing I do is try to figure out what are my unknowns. So in this question, she has phones and she has televisions or TVs. So I'm going to let something be the number of phones and let something be the number of TVs. All right. Okay, so once I've identified what my unknowns are, I'm going to look at that comparison sentence. I'm going to look to see what's mentioned last. So the last thing mentioned is the number of TVs. So I'm going to let X be the number of TVs. Then it says the number of phones that we're looking for is 5 less than double the number of TVs. So 5 is the number 5. Less means subtract. And then means we're actually doing subtract 5. Double is a word that means times 2. So if you take the number of TVs and times it by 2, so since the number of TVs is X, we're going to multiply that by 2 and do 2 times X, or 2X minus 5. So let 2X minus 5 be the number of phones, let X be the number of TVs, right? So it's 5 less than double the number of TVs. So we can't just do let statements, we actually want to do a full question here. The other thing it tells me is that there is a total of 10 TVs and phones together. So I like to start with a little word equation first before I make my real equation. If I take the number of phones and I add the number of TVs, that should give me a grand total of 10. So phones, we said were 2X minus 5. So 2X minus 5. And then plus the number of TVs, which we said was X, equals 10. And now I just have an equation to solve. So when I'm solving my equation, first thing I should do is collect up these like terms. So I have 2X plus X, that's a 1X really. So 2 plus 1 is 3X minus 5 equals 10. And then from here, I just need to solve my equation. So I would start by adding 5 to both sides. So I get 3x equals 10 plus 5 is 15. And then I'm going to divide everything by 3. And I get that x equals 15 divided by 3 is 5. Now, if this was just an equation, we'd be done, but this is a word problem. We have to go back and actually figure out how many phones, how many TVs. And the secret to doing that is your let statements. So from my let statements, we knew that the number of phones was 2x minus 5. That's what we decided to let it be. And I know that x is 5. So I'm going to take the x that's here and put in 5. So I'm going to do 2 times 5 minus 5. 2 times 5 is 10. 10 take away 5 is 5. If I check this one here, the number of TVs is x from my let statement. So x is just going to equal what x equals, which is 5. So that means, therefore, she has 5 phones and 5 TVs. You can sometimes check by just seeing, does 5 plus 5 still add to 10? Yes, it does. So when you're doing a word problem, you want to make sure you do let statements. You want to make an equation. You need to solve that equation. Then you want to go back and try to actually solve for your values, and then write a sentence. So let statements, equation, solve, find your answers, write a sentence. And that's how you do a number problem.